This video is for Chapter 4, Section 4.2. It's models for greatest common factors and least common multiples. We'll use linear models to illustrate these concepts, and you don't need other materials. We start off with mentioning that greatest common factors and least common multiples frequently arise, and we give an example of a greatest common factor. If you list all the factors of 12 and all the factors of 18, then mark the common factors, in this case 1, 2, 3, and 6, then the greatest of those common factors, 6, is the greatest common factor of 12 and 18. Similarly, if you look at the multiples of 12 and the multiples of 18, you can see that they have common multiples, and you can see they're marked here. The first one is the least common multiple. In this activity set, we're going to use rods, cutting rods up for greatest common factors and putting rods end to end for least common multiples. In question 1, we do the greatest common factor. We look at the two numbers 24 and 36. You can see that if we divide the rods up into lengths of 6, that's common to 24 and that's common to 36. 6 is a common factor of 24 and 36. Then we give you some rods to work with on your own, and we point out that there's 5 other ways to cut up 24 and 36 with same lengths, common factors. And don't forget about 1, and you have an opportunity to list all these common factors. Then in question B, we have you write down all those common factors, and in part C, we have you circle the greatest one to find the greatest common factor of 24 and 36. This is supposed to help you build intuition for understanding greatest common factors, and number 2 continues that work. In question 3, we get the greatest common factor of 12 and 20 and just sort of set that aside in our head. That's a warm-up for part B. In part B, we look at the difference between 12 and 20. So you can see that 20 is 8 longer than 12. And if you look at the rod made up of that difference, the difference rod 8 and the shorter rod 12, then you can find the greatest common factor of 8 and 12, which you'll immediately notice is the same as the greatest common factor of 12 and 20. In question 4, we talk about that at length, about how looking at the difference rod and the two originals actually lines up, and so you should read that carefully and think about it. Then you get a chance to do some calculations with difference rods. And then number 5, we have you keep going with this idea to think about how you can compute greatest common factors with using difference rods. It's just one of many techniques. Then we switch to least common multiples. In this diagram, we have a 3 and a 5, and then multiples of 3 and multiples of 5. You can see the first place they line up is 15, then they line up at 30, and of course if the diagram continued, they'd line up at 45, 60, etc. But the least of the common multiples is 15. We ask you to draw pictures. For example, we have a picture here of 8 and 12, where you line up the rods and find out where they have common multiples. You'll have extra or not enough squares here. Multiples could go on forever. You'll certainly have too many to find the least of them though. Then in question 7, we talk about the relationship between the greatest common factor and the least common multiple. For 6 and 15, the greatest common factor is 3 and the least common multiple is 30. How are those related? If you make a table, you'll see that if you have 6 and 15, when I multiply 6 times 15, I get 90. And when I multiply 3 and 30, the greatest common factor and the least common multiple, I also get 90. So fill this table out and look for that relationship. It's a nice way to determine greatest common factors and least common multiples if you already have one of them. And then write a little directions on how that actually works out. Number 8 is a bit more practicing connecting those ideas. I hope you have fun with activity set 4.2 and thinking about how to compute with models greatest common factors and least common multiples.